Hello everybody. This video is not really going to encounter any problem solving, but rather just an introduction to capacitors in series and in parallel. So over here, we see that we have three capacitors, C1, C2, C3, and we see that when the current comes off from this side, it reaches a junction point. So it has like sort of a choice. It could flow this way or this way. So we know that these capacitors are in parallel. And over here, we see that this is the positive side of the terminal. So conventional current is going to come out this way, travel through this capacitor, and the next capacitor, and return back to the battery. So there's only one direction the current flows in. So we say that these capacitors are in series. Okay, so I'm going to return to the parallel resistors now. Oh, sorry, the parallel capacitors now. And the way we can calculate the equivalent capacitance, meaning if I replaced all three of these capacitors with one capacitor, I would say that CEQ, or equivalent capacitance, is C1 plus C2 plus C3. Parallel is relatively easy because all I have to do is just sum all the capacitance of each one. And for series, it's a little bit more complicated. The equivalent capacitance is given by 1 over C1 plus 1 over C2 plus 1 over C3, and that would be how we get that value. So notice how this is kind of different from calculating resistance. For parallel resistors, it was 1 over Req is 1 over R1 plus 1 over R2 plus 1 over R3. But these are capacitors. These aren't resistors. These are things that store charge. And remember, for resistors in series, it was Req is R1 plus R2 plus R3. So a good way to remember how to calculate equivalent capacitance is to say that they're the opposite of the way to calculate equivalent resistance for series and parallel circuits. So I hope this video kind of cleared up that problem.